Programming languages tend to have some basic types already defined, and Python is no exception. So Python already knows about booleans, strings, integers, floats, long integers, and things like that. So the goal in this lecture is to introduce you to some of those basic types and how to interact with those types via the interpreter. The first type we'll look at is the booleans. So on the left, I have some booleans to print, and you can see that the Python will print true or false and start performing some basic operations like true and false and true or false. So that's for the booleans, but you can also create booleans from integers and comparison operators on those integers. And you can also combine those booleans with and or not to create more complicated expressions. So you see here a string of them. For instance, a equals 6, this tests equality. So you can see here the difference between testing an equality and an assignment. One uses 2 equal marks and the other one just 1. This tests that a is less or equal to 7. So this would return true in this case because a was assigned the value 6. If a is different from b, and then you can start composing with more complicated expressions. So I want to attract your attention to number 8 here, which involves 2 operators, not and or. And so comes the question of which precedence Python gives to those operators. So it's well defined and it's always the same. But is it not that has precedence or that has precedence? And you see that what has precedence here in this case between not and or is not, because this is the first expression without brackets, and here you have 2 different ways of bracketing that expression, and you see that the output only matches in the last one. So the output of the 8th one matches the 10th one, but does not match the 9th one. Okay, so that's for basic operations with booleans, comparing booleans and doing binary operations or unary operations on them. Now you can also use conversion to create booleans. So if you just ask bool and then you don't put anything in those brackets, you get false. Bool 0 will create false as well. Bool 3 will create true. Bool of a string that contains something will return true. While bool of an empty string returns false. Bool of a list, so this is a list that we'll see later, returns true. Bool of an empty list returns false. And bools of a list of zeros returns true. So in general, the recipe here is that bool of anything that feels empty will be false, and everything else will be true. Okay, so this was for booleans, and just like before, we created some booleans using comparisons of integers. We can also create booleans by comparing strings, or using strings. So let's say x is some words, then we can print 1, and then whether x is equal to some or not, and in this case it would be false. And whether x is equal to some words, well, that's true. We can also do different operations on this, so on those strings, and in particular use something that's called short-circuiting. So this is kind of a gimmick, but it's useful to use sometimes. So this here uses what we just saw, the Boolean conversion on top of the binary operators to produce something. So what is it exactly? Well, this is an OR. So Python knows that as soon as one of the 2 sides is true, that's the whole expression will be true if you want, except that it does something slightly differently. So what it does here is that what I've asked here is to do an OR of 2 strings, A and B. So the first step that Python will do is it will try to convert those strings to Booleans. And it will convert first the string A to Boolean and immediately realize that this is true. This gives it true because A is not an empty Boolean, an empty string. So, okay, so this gives true. So the OR operator knows immediately that one of the 2 sides is true. So in that case, it will pick the first side. It will pick the first side because the first side was true. And the first side, it will not return true. It will return the string A. And you can see this is printed here. Now this is the next case where again you are doing OR of two strings, but the first one is empty. So the first one would convert to the false boolean. So the OR here gives it when Python tries to evaluate it, the first side gives false. So Python knows it still has to evaluate the second side, converts it to boolean, and gets true. So in this case, it returns this side, so it returns C. And you can do some more complicated things as well, like doing OR of two empty strings, and this will give you the empty string, doing AND of two empty strings, and this will give you the empty string as well. So, and you can do more complicated expressions like that, and I'll let you look at it in detail. Okay, so this was for the strings. Now, with the integers, you can do arithmetic operations as well. So these are some basic ones. You can do additions, subtraction, changing signs. You can also ask the type of a variable. It would return int here, telling you that the type of A is an int, the type of B is an int. Okay, now you can also divide two integers together. So remember here, in this case, A is 10 and B is 23. So if I copy paste this, I get 0 and 2. So what Python does in this case is integral division. So it gives an integer and it tells you basically how many times here B fits in A, or how many times here A fits in B. Okay, so this was for integral division. You can also compute the remainder and do absolute values and powers and things like this. So this is all done in this way. So this double star computes an exponent, a power, or you can make it explicit with pow like that. So this was for basic operations with the integers. Now some more basic operations, but this time with floats. So a float is just assigned in the following way. We just type the number with a dot to indicate that it's a decimal number. Then we can print the type, which is float of that. Note that if we wanted to assign to E, let's say, the float 5, if we just type this, that won't work. This would give us a type for E of int. So instead, what we can do is just type 5 dots, and this gives us a type for E of float. Okay, so this was for float, but then we can start converting between the different types. So we can convert the float B that was assigned here. So I remind you that B was 23. So we can convert the float to an integer. Well, this is already an integer, so I think there's a mistake here. The float C, sorry. So we went convert the float C to an integer, and here we get that. So C was before 66.6, and then we convert and we get 66. So you see that the rounding might be a bit off sometimes. We can also convert an integer to a float. So A at the value of 10, so we can convert it in this way to a float, and we get 10.0. We can also print the result of dividing two floats together, and we get things like that. So there are different operations on floats you can do. You can do simple division, floored division, and div mod. So it gives you, it returns a tuple of the remainder and the result of the division. So div mod, two floats. So this means that 2 times d is 2 times d plus 6 dot etc. gives you c, right? So okay. So floats are just approximations. So sometimes there are weird things that happen. So for instance here, I can ask for 0.1.0.2. It displays 0.3, but the value is not exactly 0.3. Or I can round 2.675 to 2 digits, and I get 2.67. So there is some uncertainty here, or some, well, it's not uncertain, but some very complicated things that have to be decided when manipulating floats. There's also long integers in Python that allows you to manipulate very, very large types, very, very large integers, so arbitrarily long. So for instance, I can define here a long integer called very long to be a lot of 9s, and you can see here that the type of very long is a long. I can also assign some floating point number to the mass of the universe. So this is 10 to the 53, and you can see that I've created a float here. Okay, and then I can do conversions with between types. So here, if I do the conversion for the mass of the universe, it was 10 to the 53 to a long, I get this number, and you can see that this 10 to the 53 was actually stored in memory as an approximation. And I can do other things like compute large powers, yes, and the result would be a long, and I can print it and convert it to float. So this was for all the basic types, a very short introduction to the basic types in Python.